Hi, my name is Martin Smith, and I'm going over a galaxy model based on gravity chain, gravitational drag, and the idea that the jets coming out of black holes actually shape what a galaxy looks like. So the general concept of gravity chain is that if you have two masses at a set distance, they'll have certain force between them. But if you were to take those masses and divide it up by 3, say take the same amount of mass, divide it up in 3 points, because those 3 points are closer together, they would have a stronger gravitational effect to them. And in the gravity chain, we have a chain of objects that are close enough to have gravitational links. Some of them are close to the center of the galaxy, and some of them are at the edge of the galaxy. So what's happening is that the ones close to are being given lots of energy for rotational energy, and through that chain that energy is being transferred to the outside masses, and it's making them whip out and go faster than what they would normally go faster, say if they were in a solar system rather than a galaxy. The gravitational dampening, I haven't really just come up with a good name for that one. I called it the Great Slow as a joke because it seemed funny. I put it on the internet, and it just keeps coming back to me like this is something that is actually there. So I looked at the galaxies again. I typed in Hubble galaxies and looked for Hubble images. You have to be real careful not to pick up on the artwork. The artwork gives all sorts of strange stuff that doesn't really exist. So, but anyhow, the Great Slow, what I was doing with that one is saying that if you have two objects traveling this direction, now if they're moving fast and they're most likely spinning around each other, they're in orbit, but thinking of them this way, if they're moving from here to here at a certain pace, then the gravity waves aren't instant. They move at the speed of light. So the distance, the time it takes for that light to get across, it's not a straight line. Its gravitational effect is actually behind the two objects, not side by side. And having it slightly behind is going to create a force to slow the thing down. So the faster it's moving through space, the faster it's going to slow down. The closer that those two objects are together, again, that means the faster they're spinning, and also the faster they're going to slow down. And the closer to the same size those two objects are would also come up to the same thing. It would increase the drag on the two objects. So if you have one object that's, say, a million kilotons, and another object that's just a ton, the slowdown effect would be very, very small, such as Mercury compared to the Sun. So as Mercury and the Sun travel through space, the effects of the slowing of those two objects would be incredibly slow. However, if we had a binary star system, the slowing down would be very, very slow. And if you look at Hubble images of galaxies, you will notice that as those arms go out, some of the objects are actually behind as the arms just sort of split up. So over time, as we as binaries are binaries, or while they're binaries, they're going to be slowing down quite a bit. And when they merge, all of a sudden they're not slowing down anymore. When stars are individual, even individual stars attract other stars, and they come together and become binaries. So there's going to be some effects in there. There's going to be, if we look at the arms in which the mass forward, they're going to be just about all singular stars, where the binaries would be towards the back. And no, this I have no proof of that particular thing. I am just deriving this bit from what a gravity slowdown would actually do. I'm just saying this is what it should do, and it may not. So maybe somebody will take a telescope and actually look out there and calculate the differences between the two. Who knows? But time to do the paperwork on it. Galaxy model versus gravitational slowing down, or gravitational siphon. So I'm looking at here having a gravity chain. Center black hole, so there's very little mass here in the black hole compared to the rest of the galaxy. There's a large quantity of mass around stars next to the black hole, that big bulge that's in the center of galaxies. And then we have the bars that are coming out, and these are jets that are pushing particles and other things out. So all this mass around the center black hole, these jets are hitting it and pushing dust and other things out here, and the masses build up, and all of a sudden we have large masses at the end of the points of the jets. So from there, the galaxy is sort of being put together as the black hole gets smaller, and as the jets push out material, the mass gets put more towards the outside than the inside. So like I said, the gravity chain, we're taking multiple masses, and those masses are what's keeping this thing together. It's very similar to going roller skating or ice skating, and you get a whole bunch of people holding hands. One person stays in the center, and the people in the middle can get whoever's on the outside to go around the circle at a very high speed. And that's pretty much what gravity chain, or the idea of gravity chain, is. Let's see here, the great slow down here. So we have two objects moving in this direction. What's happening is from here to here, the velocity it takes to go from here to here being the same amount of time it takes for gravity to go from here to here. It's not going straight across, it's actually coming back a little bit. So we can use vectors here to give us the differences of those. So in theory, this would be slowing down any binary stars or any planets that are within orbit around themselves. The basic idea is the binaries would slow down the most, the single ones would slow down the least. And coming back up here, this is the reason I say stay away from art, because I did this myself, and rather than redoing it, I said, well, this would be a great example of why art really gets people in trouble. This arm that I created, it's not straight. I created this one here straight, but what happens is this one here would be straight, and then this one would curl off from it. This one would be slowing down and getting away from the main arm. And that's what I'm seeing when I see galaxies. Not saying that that is the reason. I'm just saying that this is my interpretation of what I am seeing. So that wraps this one up, and if you come up with some other ideas of how galaxies are made, put it on the internet. I want to watch it, and I'll see you later.